Hello and welcome everyone to the video. In this video, we'll be looking at time, speed and distance as a topic. And before I move on to the video and I start talking about the topic and the concepts of time, speed and distance, let me say a few things about time, speed and distance. Now, the only thing that I want to happen after this video is that you should change your ways of looking at time, speed and distance data which is given on the question. So we have a standard or a conventional approach towards time, speed and distance, wherein we try to equate speed, or we try to equate time, or we try to equate distance according to the question, and then try to make equations which sometimes turns out to be very, very lengthy to solve. I am not saying that you will not be able to solve the questions by those approaches. You will definitely be able to solve those questions with the help of those approaches, but then the problem is it's going to take a long time, and which is what you don't have on the paper. So once you are done with this entire video and once you are through with the entire set of concepts, please, I will give you a certain set of questions also in the video today, wherein we will try to apply those concepts. And post that, when you are doing your preparation, I really want you to ensure that you look at the data with a different perspective altogether, which you will gain eventually when you look at this entire video. So without any further delay, let's move on and try and look at the basic concept of time, speed and distance. We all are aware about a very simple formula of speed being equals to distance upon time. So that is how your speed is defined, that how much distance have you traveled per unit of time. So that unit of time can be an hour, or it can be a second, it can be a minute, it can be any of these measurements of time. And based on that, how much distance have you traveled is what your speed is. So speed is equals to distance upon time, a standard formula, nobody can change that. Right now, one thing that you need to look at when you do apply this formula of speed is equals to distance upon time is units. So you got to ensure that your unit consistency is maintained across. For example, let's say suppose I wish to calculate the time taken to travel a distance of 500 meters when I'm traveling with a speed of 50 kilometers per hour. Now, if I use this set of data over here in this formula in the same units which is present over here, then I'm not going to get the correct answer. I will get the answer corresponding to the time required to travel 500 kilometers, right? Because the unit consistency need to be maintained. So when you are taking speed as kilometers per hour, you're already deciding the unit as kilometers, and the unit of distance is kilometer, and the unit of time as hours. So the output will be in hours, and the value of distance that you have to use has to be in kilometers. So instead of using 500 kilometers, you will have to use 0.5 kilometers to be able to get down to the correct answer. And of course, the answer will be in the unit of hours, right? So that unit consistency is something that you need to maintain, right? There's one more thing which happens when you look at unit conversions, and say that at some point in time, it may happen that you will not look at these units. Now, what is that time when you don't look at the unit consistency? For example, let's say suppose speed of A upon speed of B is in the ratio of let's say suppose if your distance is constant, then it is in the inverse ratio of time. From where am I getting this is eventually something that I'm going to talk about. As of now, just say that if this is the case, then let's say suppose speed of A is given to me in 10 kilometers per hour, speed of B is given to me as 20 kilometers per hour, and time taken by A is given to me as 50 minutes. Now I can use this data in the present format itself and can simply say 10 by 20 to be equals to speed of B, time taken by B, I don't know, let me take that as X, and divided by 50. Now you may come back and tell me that, sir, this was in 10 kilometers per hour. So why are we not converting this 50 minutes to hours? Now the point is, over here I've taken the ratio. And what is the ratio that you are getting? You are getting 1 by 2 as the ratio, correct? Even if you convert this kilometers per hour of speed of A and B to, let's say suppose kilometers per minute, in that case also, you will realize that the ratio will still remain the same. So when you are taking the ratios, the units does not matter. So when you take the ratio of 10 kilometers per hour to 20 kilometers per hour, it will be 1:2. When you convert these two speeds in meters per second, and then again take the ratio, you will realize that the ratio will still remain 1 by 2. So when you are dealing with ratios, at some point in time, we might not look at the unit consistencies, and that's okay. That is also pretty much logical. There's one more unit conversion that I want to bring to your notice, and which I want you to keep on your mind, because that's something that has been often used on the questions. So let's say suppose if I wish to convert 50 kilometers per hour as the speed to, let's say, suppose into meters per second, then what should I be doing? So 50 kilometers per hour, a kilometer has got nothing but 1000 meters, and an hour has got how many seconds? Hour has got 60 minutes, and every minute has got 60 seconds. So you will do a 60 into 60. So you will get 3600. So what we'll get? We'll get 5 by 18 over here. So when I wish to convert kilometers per hour to meters per second, I will multiply it by 5 by 18 as a factor. And when I wish to convert from meters per second to kilometers per hour, I will multiply this by the inverse of this, which is 18 by 5. Right? So this unit conversion is something that I want you to keep in your mind. You should not be doing this calculation during the paper because that's a waste of time. So if you're preparing, then you should keep all of these things in your mind, right? Let's move on to the next concept of time, speed, and distance, which is, to my mind, a very, very important concept and a use of ratios to solve time, speed, and distance problem. And this is what I was talking about, that once we are through with the concept of this, we must ensure that we look at things in a slightly different perspective. Now, let me take you through this concept and then we'll talk about it. So let's say, suppose there's a person A and there's a person B. A is moving at 10 meters per second and B is moving at 15 meters per second. Okay. Now, both of them, so this was their speed. Let's say, suppose both of them says that we're going to travel for the same time period. So they wish to travel for the same time period. They say that I'm going to travel for 10 seconds. Each of us going to travel for 10 seconds. Then in that case, what is the distance traveled by A? The distance traveled by A will be nothing but 100 meters. Distance traveled by B will be what? 150 meters, right? Now, I want you to pay attention to something. What is speed of A by speed of B? Speed of A by speed of B is 10 by 15, which should be 2 by 3. Speed of, now the same thing, distance traveled by A divided by distance traveled by B is what? 100 by 150, which is going to be what? 2 by 3 again. This brings us to an important point, which says that the ratio of these speeds is in the direct ratio of their distances is equal to the direct ratio of their distances when my value of time is constant. When my value of time is constant. Now, why am I saying time constant? I am saying time constant because the period for which A and B were traveling is the same. The time period for which both of them were traveling was the same. They were traveling for 10 seconds each. Now, this 10 second can be any stretch of 10 seconds in a day, right? It is not necessary that it has to be a specific stretch of time. The quantum of time should be same is all what I'm trying to say. So if A is traveling for 10 seconds, B is traveling for 10 seconds, it doesn't matter when are they traveling in the day or in which days are they traveling, doesn't matter. What matters is how much time are they traveling for and is that value of time same? Now, if that happens, then I'm directly going to say that the ratio of the speeds of A and B should be equals to the ratio of their distances. By time constant, I don't mean a specific time. I mean the quantum of time being same, right? So this is one part of it. Let's take another set of data with the same condition that, let's say, suppose speed of A is still 10 meters per second, speed of B is still 15 meters per second. 10 meters per second and 15 meters per second, and these are the speeds. So let me put the data over there. Now, let's say suppose they say that we wish to travel for the same distance. So let's say suppose both of them are trying to travel a distance of 300 meters. Now, in this case, what happens? How much will be the time taken by A to travel a distance of 300 meters? It's going to be 30 seconds. What will be the time taken by B to travel a distance of 300 meters? That's going to be 20 seconds. Right? Now let's take the ratio of their speed, speed of A by speed of B. That's going to be 10 by 15. That's going to be 2 by 3. Same way, let's take the ratio of their time taken, TA by TB. And that will be what? 30 by 20, which will be nothing but 3 by 2. So can I then say that when my value of distance is constant, that means they wish to travel the same quantum of distance, then the ratio of their speeds should be in the inverse ratio of their time period, isn't it? Speed of A by speed of B should be equals to time taken by A by time taken by B by A. So speed of A by B was 2 by 3, and this should be inverse of this. So this will then become 2 by 3 as well, right? So we need to be very careful during the question as to what is constant. Is my distance constant or my time constant? Now, of course, they will not explicitly mention this thing on the paper or on the questions. You will have to read the question and try and question yourself. if time is constant in this, or in this data distance is constant. Whichever is constant, according to that, we will apply our ratio. Now, you don't really have to mug up these ratios. What you simply need to do is to keep this formula on your mind. Speed is equals to distance upon time. When your distance is constant, speed will be in the inverse ratio of their time. So speed of A by speed of B is equals to TB by TA. When your time is constant, then the ratio of their speeds will be equal to the ratio of their distances traveled. So with the help of this itself, you will be able to remember both the statements, right? So pure logic. There's no formula that I'm asking you to mug up. I just want you to read the question and realize what is constant. In majority of these questions, examiner will have to keep something constant to be able to make the questions. And trust me on this, this is one single tool which helps students a lot while solving time, speed, and distance problems, right? Let's move on. One more concept, which is that of relative speed. Now, relative speed is something which is to my mind a less understood concept in terms of the practical sense as to what speed are we talking about, which distance is increasing at what rate to call it as a relative speed, right? So what I want you to do is to ensure that you practically understand what do we mean by relative speed. Which distance are we talking about? Speed is what? Distance is increasing at a certain pace. So if I say speed is 10 meters per second, the distance traveled is increasing at a rate of 10 meters in every second, right? When I say relative speed is 10 meters per second, which distance am I talking about? Who is traveling that distance? These are those important questions that if you are able to answer in your mind, you are clear with respect to the concept of relative speed, right? So let me help you out with this. Let's say there are two of them, A and B, both starting at the same point, same time, A and traveling in the same direction. So A is traveling at, let's say, suppose 10 meters per second, and B is traveling in the same direction, again at 15 meters per second. Now, both starting at the same point, same time. That means at time period 0 seconds, the distance between the two of them was 0 meters. After 1 second, what will happen? A would have traveled 10 meters, but B would have traveled 15 meters. That means the distance between the two of them would have become what? 5 meters. At the end of 2 seconds, what will happen? In 2 seconds, A would have traveled 20 meters, B would have traveled 30 meters. Distance between the two of them would have become 10 meters. At the end of 3 seconds, the distance between the two of them will become 15 meters. Can I then say that the distance between the two of them is increasing at a rate of 5 meters per second? And this rate at which the distance between the two is increasing is called as the relative speed. This is the relative speed, which is 5 meters per second. And how have I got down to this 5 meters per second? We have done what? We have taken the difference of the two speeds, which is 15 minus 10. So if you remember, a lot of time this is being told to you as a statement that if they're moving in the same direction, then I'm going to take the difference of the two speeds. This is the reason why we say that the difference of the two speeds will give you the relative speed of the two of them. So the rate at which the distance between the two is increasing is called as the relative speed in this case. Now, when they're moving in the same direction, is it necessary that the distance will always increase? No, it is not necessary. It may happen that the distance between the two is decreasing when they're moving in the same direction as well, right? So let me give, that depends of course upon the opening condition. So let's say suppose B is over here and A is over here. Both are at different points to start with, and they're moving in the same direction. A is moving at 10 meters per second and B is moving at 15 meters per second. Now, what will happen? Let's say suppose this distance between the two of them was 500 meters to start with. At time t 0 seconds, the distance between the two of them was 500 meters. At the end of 1 second, what will happen? At the end of 1 second, B would have traveled 15 meters over here, but A would have traveled only 10 meters over here. So the distance between the two of them would have reduced and would have become 495, right? What happens next? After 2 seconds, the distance between the two of them would be 490 seconds. That means now the distance is reducing at a pace of same 5 meters per second. So it doesn't matter whether the distance is reducing or the distance is increasing. It's just that it is happening at that pace of 5 meters per second, and we'll call it as a relative speed. If they're moving in the same direction, I'm going to take the difference of the two speeds and call that as the relative speed, right? This is the meaning of relative speed. Now let's understand, if the two of them are moving in the opposite direction, then what happens? So let me say that there's a person A over here, there's a person B over here, both starting at the same point, same time, but in this case, moving in a different direction. So B is moving at a rate of 50 meters per second and A is moving at a rate of 10 meters per second. Once again, at time period t equal to 0 seconds, the distance between the two of them will be 0. At the end of 1 second, what will be the distance between the two of them? A would have moved 15 meters in this direction. Sorry, B would have moved 15 meters in this direction. A would have moved 10 meters in this direction. Distance between the two of them would have become 25 meters. At the end of 2 seconds, the distance between the two of them would have become what? B would have traveled 30 meters, A would have traveled 20 meters. Distance between the two of them would have been 50 meters. At the end of 3 seconds, it should be 75 meters, right? So on and so forth. We now realize that the distance between the two is increasing at a pace of 25 meters per second. And this 25 is nothing but my relative speed when they're moving in the same direction. And how have I got down to this relative speed? That's the sum of 10 and 15. That's the sum of 10 and 15, which is 25. So if they're moving in the opposite direction, I'm going to take the sum of the two speeds as the relative speed. Now, once again, over here, the distance was increasing. Is it necessary? No, it is not necessary. If they're moving in the opposite direction, the distance may reduce as well. For example, you may have A over here. You may have B over here. A is moving in this direction at 10 meters per second. And B is moving in this direction at 500, at let's say suppose 15 meters per second. And let's say the distance between the two of them is 600 meters. So what will happen? At the end of 2 seconds, at the end of 1 second, what will be the distance between the two of them? A would have moved 10 meters, B would have moved 15 meters. That means out of the 600 meters, they would have covered 25 meters. So the leftover distance will be 575 between the two of them. At the end of 2 seconds, the leftover distance will become 550 between the two of them. Then it would become 525 over here after 3 seconds, right? So the distance between the two is now reducing at a pace of 25 meters per second, which is again going to be the relative speed, right? Now, there's one last thing that I want you to keep on your mind. At a lot of times when you are looking at relative speed, you will apply the formula of speed is equals to distance upon time. But you need to understand that if you are looking at relative speed over here, you will have to take the value of relative distance over here. For example, in this particular question, if let's say, suppose the question is that when are they going to meet each other? After how much time? So I'm going to say that this distance of 600 meters over here need to be covered at a relative speed of 25 meters per second. So now I am using what? Is 25 meters per second speed of A? No. Is it speed of B? No. It is the relative speed. Same is the case with this 600 meters. Is it the distance traveled by A? No. Is it the distance traveled by B alone? No. It is the relative distance traveled. So what am I going to do? I'm going to say 25 should be equals to 600 divided by time period and calculate the value of T from there, right? So be very careful. If you are using relative speed, then ask yourself that I'm not going to do the absolute distances traveled by them, but rather I will be using relative distance traveled by them, right? So keep this on your mind. And now we move on to the next part of the video, which is questions. And as usual, the drill remains the same. I'm going to give you a certain amount of time to do these questions, and then we will discuss it on the screen, right? So let's move on. Let's try our first question, an easy one. A minute's time for you to solve this question. Last 15 seconds. Right. Not a very difficult one. It was an easy one. So let's quickly get over this. It says A takes 40 minutes to travel a certain distance. One day he decreases his speed to 80% of the normal speed. How much time it will take for him to travel a distance which is 4 times the distance that he used to travel? Okay. Now let's understand this thing. He's taking 40 minutes. Now with the normal speed. So let's say suppose the usual speed is S and the usual time taken is T. In this case, it is 40 minutes. Okay. Now, if he reduces his speed to 80%, what is 80% corresponding to? 80% corresponds to 4/5 of the normal speed. 4/5 of the speed is nothing but 80% of the speed, right? How much time will it take? Let me call that value of time as X. This value of time is 40 minutes, right? So I can get down to this value of time period over here, which is X. That will of course be in minutes. Now we need to understand what are we saying. We are saying that my value of distance is constant. Every time in either of the case, it is traveling the same distance. I will come back to this 4 times the distance a little later. Let me say that if the distance remains the same, then in that case, what will be the time taken by him? In the case when the speed is reduced to 80%, right? So when distance is constant, what do we say? When the distance is constant, the ratio of their speeds is in the inverse ratio of their time period, TB by TA, correct? What is the ratio of their speeds? So you have S divided by 4 by 5S should be equals to TB by TA. Now, whatever is the speed you have kept in the numerator, the corresponding time you will keep in the denominator on the other side of the equation. So you will put 40 over here because that was in the numerator. So corresponding time should be in the denominator. 4 by 5S, I don't know how much is the time period. So I'm taking that value as X. S will get cancelled out. So what are we left with? We are left with 5 by 4 is equals to X by 40. So you will realize that the value of X will be what? 50 minutes. So now for the same distance D, the time taken will be what? 50 minutes. Now, if I have to keep 4 times of this distance, then I will require 4 times of this time, isn't it? 4 into 50, that should be 200 minutes. Please understand this thing. 50 minutes you will always find in the option choice. Please don't be in a habit of taking X as your answer anymore in any of these aptitude paper. I want you to find out, take a variable, find out the value of that variable. But then before you mark the answer, please read the question again and see if that is what they have asked you. So in this question, they're not asking me the value of X. They're asking me how much time it will take to travel 4 times of that distance. So it will be 4 times of this particular time. So 4 into 50 will be 200 minutes. Now, once again, I had not thought about converting minutes to seconds or for that matter, any of these things. Why? Because we were looking at ratios. Let's move on. Let's look at the second question. And you will again get a minute's time to solve this. Not a very difficult one. Last 15 seconds. Let's try and solve this question. Now, again, it is not a very, very difficult question, but once again, I want you to pay attention to trying to figure out as to what is constant in the question. And if you take that, then the question becomes a lot easier. A and B start traveling towards each other from the point P and Q respectively. So you have a point P, you have a point Q, and A and B starts traveling towards each other. A is traveling in this direction, B is traveling in this direction. Okay. They meet at a point R. Suppose they're meeting at some point over here, R, and they continue their journey towards their destination. A reaches the point Q and returns to the point P. That means A is taking the entire journey from here. It goes and takes the entire journey and comes back to this point. Okay. Now, if both reaches the point P at the same time, B is traveling from here and is reaching the point P, both are reaching the point P at the same time, then what is the ratio of their speeds? Now understand this thing. Both of them start traveling towards each other at the same point in time, right? And they are reaching the point P also in the same point in time. So can I then say that both A and B have ended up traveling for the same time period right from the very beginning to the time when they are meeting at the point P? correct? So can I then simply say that my value of time is constant? If my value of time is constant, then my ratio of their speeds must be the ratio of their distances traveled, right? I don't know what is the ratio of their speeds. That's what I have to figure out. So speed of A by speed of B should be equals to the ratio of their distances traveled by A. Now look at this distance traveled by A starting from this point, going all the way up to the point Q and coming back. So let me say that this distance was equals to X. So what is the distance traveled by A? The distance traveled by A is 2x. What is the distance traveled by B? B is reaching from the point over here to the point over here. So it's the distance x. So can I then simply say that 2:1 will be the ratio of their speeds, right? Again, a very simple question where if you keep time constant, you will be able to get down to the answer. I am nowhere denying the fact that you can go by the simple formula of speed is equals to distance upon time and can still do the question. So you can take the time taken to travel for A from the point P to Q and then coming back from Q to R. That time period is equals to the time period taken by B to travel from the point Q to P. Now, that is something that will give you the answer, but in your paper, you will have a lot of students who would be really fast at it. And if you really wish to beat them out on the paper and get a better score than them, then you got to be faster, as at least, you know, equivalent to those set of people. So we will have to learn these concepts. Let's move on. Let's look at the next question and take a minute and a half's time to solve this. Last 30 seconds. Let's now try and solve this question. It says in a 500-meter race, A can beat B by 100 meters. That means when A is traveling a distance of 500 meters, B is traveling a distance of 400 meters. A can beat B by 100 meters and C by 250 meters. That means in the same time period, C will be traveling 250 meters. A completes the race in 50 seconds given to you. So if A is completing the race in 50 seconds, then in the same time period, each one of them is traveling the given distance, isn't it? So if I know the distance and if I know the time period, can I calculate their speeds? I can do that very, very easily. This will be 10 meters per second. This will be 8 meters per second. And this will be 5 meters per second. These are their speeds in meters per second, right? Let's go further. In a 1,000 meters race, now they're talking about a 1,000 meters race, A had to reduce his speed to half after completing 800 meters. Now they're saying A is doing it in two parts, first 800 meters and then 200 meters. Then what is the time taken by A to travel this 800 meters? 800 divided by 10, that should be 80 seconds. Simple. 800 divided by 10, because that was the original speed, right? 800 divided by 10, 80 seconds. And then 200, and you are reducing the speed to half of itself, that means 5. So it will be what? 200 divided by 5, that should be 40 seconds. So can I then say that A will take a total of 120 seconds to finish this race of 1,000 meters in the given condition? C increases his speed to 10 times of his original speed after traveling 500 meters. I'm looking at C. After traveling 500 meters, that means for the 500 meters, he would be traveling with the same speed of 50 meters per second. So 500 divided by, 5 meters per second. So 500 divided by 5, that is going to be 100 seconds. So for 500 meters, it will require 100 seconds for him to complete that. But after this, the next 500 meters, he is doing it at 10 times the speed. So instead of 5 meters per second, he is now doing it at 50 meters per second, isn't it? So next 500 at 50 meters per second, he will be able to finish it off in 10 seconds itself. So the total time taken by C to finish off this race should be 110 seconds. For B, they have not given anything. So I will have to presume that it is traveling with 8 meters per second for the entire time of this 1000-meter race, right? So 1000-meter race, and for 8, it is going to be what? Say 8 ones are 8, 28, 2s are 16, 8 5s are 14. So that's 125 seconds that B will require to finish off this race, and A will require 120 seconds to finish off this race. Now, who is the runner-up? So the first person would be C to complete this race. Second person will be A to complete this race. So the runner-up is A. And by what margin does he beat the person coming in third? Now, understand this thing. If you look at this entire 1000-meter race, when A is just reaching at this point, B would have been where? B would have traveled this distance for 120 seconds. Correct? That means he is yet to travel for 5 seconds more to be able to complete his race, and 5 seconds at a rate of 8 meters per second. So 5 into 8 should be what? 40 meters. That means A is beating B by 40 meters. So not 40 meters per second, it should be just 40 meters, right? So who is winning the race? Who is the runner-up? A is the runner-up. And by how much distance is he beating the person coming third? He is beating him by 40 meters. So A and 40 should be the answer for this question. Let's move on and let's look at question number 4. Take your time. Last 30 seconds. Let's try and solve this one. A starts from his home for office at 9:30 a.m. every day. If he travels at 20 kilometers per hour, he is 20 minutes late to the office. And if he travels with 30 kilometers per hour, he is reaching 20 minutes early to his office. He is every day starting at 9:30 p.m. So let me say that his ideal time of travel must be T minutes of travel. Now, when he is traveling at a speed of 20 kilometers per hour, he is reaching office 20 minutes late. When he is reaching office 20 minutes late, that means he's consuming 20 more minutes of time. So travel time is what? T plus 20 minutes. Same way, when he is traveling at 30 kilometers per hour, he's reaching 20 minutes earlier. That means his travel time is 20 minutes lesser than the required time period, the ideal time period, right? Now, every time is not the distance travel same. So can I then say that my value of distance is constant on this question, right? Because every time he's traveling from home to office, so that distance is going to remain the same. So if my distance is constant, then the ratio of their speeds is in the inverse ratio of their time period. Is in the inverse ratio of their time period. What is the ratio of their speeds? 20 by 30. What is the ratio of their time period? It is the inverse ratio. So 20 was the speed over here in the numerator. So T plus 20 must be the time period in the denominator. So this should be T minus of 20. We have to solve it for the value of T. So let's do this. You will get 2T plus 40. That should be equals to 3T minus of 60. That means the time period must be 100. And this time period is nothing but 100 minutes. Now, once again, I'm not going to mark 100 as the answer because I'll have to look at it as to what they've asked you. What should be his ideal speed to reach the office exactly on time? They're asking you the speed to reach the office on time. So now I know it is traveling at 20 kilometers per hour. T plus 20 is available with me. Value of T is there. So T plus 20 will be what? 100 minutes. Sorry, 100 plus 20. So that's going to be 120 minutes. Correct? So what will be the distance traveled? Distance is nothing but speed into time. What is the value of speed? 20 kilometers per hour. Time period over here was what? 120 minutes. 120 minutes is nothing but 2 hours. So you will have to look at what? 40 kilometers as the distance. So what should be the ideal speed to reach the office exactly on time? 40 kilometers is the distance. Time period is 100 minutes. So 100 minutes, if I convert this into hours, so that should be 100 by 60, and that should be 5 by 3 hours of travel. And 40 kilometers is the distance. So what will be the speed? Distance upon time. 40 divided by 5 by 3. So this is 5 8s of 40, 24 kilometers per hour must be the ideal speed to reach the office on time, right? Please do not mark 100 as the answer. Do not mark 40 as the answer. Be careful. Read the questions very carefully. Don't make errors which are unnecessary on the paper, right? Let's move on and let's try question number 5. Take your time. Take about 1.5 minutes of time. It's an important and might be a slightly lengthy question. Take your time. Last 30 seconds. Let's try and look at this question. It says what? A and B starts traveling towards each other simultaneously from the point P and Q. The ratio of their speeds is given to me as 2:3. They meet each other and return to their starting point. So A and B are starting to travel to each other from the point P and Q respectively. So A is starting from here, B is starting from here. This is the point P, this is the point Q. Now, their ratio of these speeds is given. They meet each other and return to their starting point. So ideally, what will happen? They will meet somewhere over here and A will go meet B and come back. B will go from here, meet A and come back, right? So this is going to be the journey. Now, on one day, A starts 30 minutes earlier. Now let us understand the second situation. What happens? You are saying P to Q over here. And you are saying A is starting 30 minutes earlier than his usual time. So A will reach this point. Let's say suppose this point was C, where they were meeting. So if they were meeting over here, this is the point C. So A will reach the point C 30 minutes prior to what is his usual time. At that point in time, your B would be at this point, right? A has reached the point C 30 minutes prior to his usual time. And D is yet to travel this entire distance in 30 minutes. D is yet to travel this entire distance in 30 minutes. Now, what is the situation? Now their speed ratio is 2:3 given to me, right? So from this point onwards, C should travel 2 parts of this distance and D should travel 3 parts of this distance. Now, earlier, D would have taken sorry, B would have taken 30 minutes to travel this distance DC. So if I look at the distance DC, time of travel by B should have been 30 minutes, correct? But now, of course, B will not be able to travel this distance because a part of this distance will be traveled by A, and they will meet somewhere over here, and then B will have to return and A will of course have to return. So now let me take this distance as 5x. Why am I taking 5x? Because I'm taking 2 and 3 over here so that my calculations remains easy. So this distance was 5x, which was traveled by B in 30 minutes. Now B will travel what distance? B will only travel 3x distance because 2x distance will be traveled by A and B will travel 3x distance. So for 3x distance, how much time B will take to travel? So for distance being 5x, time of travel was 30 minutes. Time of travel was 30 minutes. 30 minutes, let me call it as half an hour. Doesn't matter. You can keep it at 30 minutes as well. So what will be the speed? Speed would be 5x distance upon time. So 5x divided by 1 by 2. This will be the speed. Now what is going to happen? B will have to travel with the same speed, the distance being 3x. Distance being 3x. So how much will be the time taken? Let me say that the time taken is y minutes. He is taking y minutes, but the speed has to remain the same. So 3x by y, which will be the speed, should be equals to 5x by 1 by 2. So x will get cancelled out. So what we will get? Y to be equals to, just a second, y should be equals to 3 by 10. 3 by 10 hours. Let me convert this into minutes. So this was into hours. Why? Because this was into is in hours. So this should have been in hours, right? So 3 by 10 hours. 3 by 10 hours, how many minutes? Y should be equals to 3 by 10 into 60. That should be 18 minutes. Now understand this thing. Ideally, he would have taken 30 minutes to meet this person, but now he's only taking 18 minutes to meet this person. So how much time is he saving? B is saving in one way of the journey. 12 minutes have been saved. So overall journey from B to this particular point and then returning, he would have saved twice that amount of time. So that's going to be 24 minutes of time that has been saved by B in the entire journey, because ideally this time of travel for him was 12 minutes one way. So another way it would have been 12 minutes. So 12 and 12, 24 minutes of time have been saved by B to come back to the point Q. Very interesting question. This video is going to be there on the channel. So I really want you to refer to this question once again, once the video is done, and probably, sometime before the exam as well, because that gives you a certain set of ideas in your mind that you can apply on various questions. Let's move on and let's look at one last question for the day. Question number 6. Take a minute and a half's time to solve this. Last 30 seconds. Let's try and solve this question. it says a bus met with an accident 200 kilometers from the point A moving towards the point B. So you have a point A moving towards the point B. That means the bus was moving for the point B and it has met with an accident after 200 kilometers. So this is the point of accident, which is 200 kilometers from the point A. It completed the remaining journey with 2/3 of the previous speed. So whatever was the speed of the train over here, it is now going to travel the rest of the distance with 2/3 of the speed. Now distance is going to remain the same between CB. Earlier also it had to travel the distance CB. Now also it has to travel the distance CB, right? So earlier, let's say suppose the speed was S and the time period was T and the distance was D. This distance that I'm talking about over here is the distance CB. Okay. So now if I'm traveling with 2/3 of this speed, so the time period has to become 3/2 to keep the distance same, because I have to end up traveling the same distance. So this distance was S into T. So this distance also should be S into T. So time period should become 3/2. That means how much is the increase in the time? 3/2T minus of T. That will be 1/2T. That's the increase in the time period, right? And what is the question saying? Reach the point B 30 minutes later than the scheduled arrival. So this should be 30 minutes. That means the original time period, must be what? 60 minutes. But remember this thing, that this original time period of 60 minutes that you are talking about is the time required to travel the distance between CB, would be 60 minutes. I hope we are clear with this. This distance was 200 kilometers. This distance was supposed to be traveled in 60 minutes, but it was not traveled in 60 minutes. It's 30 minutes extra was taken. So actually this has been traveled in 90 minutes after the accident. Now what is the question saying? Had the accident taken place 50 kilometers further, that means, let's say suppose if the accident is taking at the point D, which is 50 kilometers further. So this value is 50 kilometers. It would be only 15 minutes late. It would reach only 15 minutes late. So that means after this point, it will travel with the speed of 2/3. So now if I take DB as the distance, again, the usual speed was S, usual time was, let's say suppose T dash. So the usual distance DB is what I'm talking about as, let's say suppose D dash, right? Now the speed becomes 2/3 of the original speed. So the time period has to become 3/2 of the original time period required to travel the distance DB, remember. That is equals to D dash. So increase in the time period would have been 1/2 D dash, and that should have been only 15 minutes given on the question. So T dash, that means the usual time taken to travel from D to B must be 30 minutes. Must be only 30 minutes. So usual time of travel is 30 minutes, right? So what will be the usual time of travel over here? The usual time of travel from C to B was 60 minutes. Usual time of travel from D to B was 30 minutes. So the usual time of travel over here should have been 30 minutes. Correct? So in 30 minutes, the train ideally should have traveled 50 kilometers. If that is the case, then in 1 hour, the train would have traveled 100 kilometers. So can I then simply say that 100 kilometers per hour is the speed of the train? Sorry, bus. And now what is the question talking about? Find the speed of the bus. That is 100 kilometers per hour. And the distance between the point A and the point B. Point A and the point B. Understand that this 200 is given to you directly, right? So you just have to calculate this distance. Time period is 60 minutes and the speed was 100 kilometers per hour ideally, right? So it should be what? 100 kilometers. This distance should also be 100 kilometers. So 100 plus 200, the total distance from A to C was 200. The total distance from C to B is turning out to be 100 kilometers. So the total distance from A to B must be 300 kilometers, right? So the answer to this question is 300 kilometers and 100 kilometers per hour. Now that brings me to the closure of the video. Please do like the video and subscribe to the channel and stay tuned for further videos on this channel. Thank you.